All right, let's do this problem together. So the average marathon runner in the U.S. runs at a speed of 5.75 miles per hour for 26.2 miles of the race. The question is, how much time does it take for the runner to finish the race? So in this one, we notice we have some information. First of all, I notice the 26.2 miles, and that cues me in as a distance. And also, I've got 5.75 miles. And notice the mistake I just made. I only read the first word. If I read more, I'd say 5.75 miles per hour. Oh, all of this is together. So make sure you're not just reading the numbers and the word after. Actually read the problem to make sure you have the right value down. So 5.75 miles per hour, that tells me that's a velocity. So I'm going to come down here and say 5.75 miles per hour. And I know I'm going to go a distance of 26.2 miles. The miles cues me that's a distance. So my change in distance is 26.2 miles. It's a pretty long run. I don't know if I could do that. And then the question is asking how much time. So our time here, our change in time, that's what we're looking for in this problem. So the next thing we ask ourselves is, well, what relates distance, time, and velocity? And of course, that's our velocity equation. V is equal to the change in distance over change in time. Now we always start with this equation. Now in this example, I'm going to show you some common mistakes that people make. So don't write this first part down. So some people say, okay, we want to get time by itself, and that's a good thing to think. So how do I get rid of this distance? Well, some people do this. They just say, okay, so now I'm going to multiply by distance. I'm going to put distance here. I'm going to multiply this side by distance. And I'm going to notice right away that, hey, people say, well, this distance and this distance cancel. The problem is distance times distance doesn't cancel. Just like x times x is equal to x squared, right? Distance times distance is equal to distance squared. So in the end, what you end up with is this equation. It's like change in distance times velocity is equal to change in distance squared divided by the change in time. So instead of making the problem simpler and solving for distance, we've just put distance everywhere now. Now we've got three distances, two here and one here. This is going to be really hard to solve for. So we're not going to go this route. Let me erase some of this stuff. So we're going to get rid of that times distance and that times distance. And then we're going to get rid of all of this. And we're going to just redo it real quick. All right. So next, how do we want to go from here? So if multiplying by distance didn't work, maybe dividing by distance will work. So change in distance, we'll put it on bottom for divide. And if I divide on this side, I've got to divide on this side. So I'm going to put it underneath here as well. So divide it on both sides. Now, in this case, we notice that there's a distance on top and a distance on bottom, and these two do cancel. But here's the mistake people then make. They'll write it as this: velocity divided by distance, which is true, is equal to, and then they'll just see over here where there's just time left. Change in time. The problem is that when distance and distance cancel, they don't just disappear, they leave behind a 1. Now normally we ignore that 1 because 1 times anything is just that thing, so we don't have to worry about it. But in this case, the 1 is on top and the change in time is on bottom. So instead of solving here for time, we have 1 over time. Time is still in the bottom of the fraction. You can't magically make it go from the bottom to the top. So it's still in the bottom. And this isn't what we're looking for. We want time to be all by itself, and now it's time underneath 1. 1 divided by time. That's no good. So let's back out of this thing too. So dividing by distance doesn't work well either. And I'm just going to erase all of this. And we'll start fresh. All right. So let's go back to our original equation. V equals delta D over delta T. And it looked like no matter what we do, we need to get time out of the bottom, because at some point we're going to have to get it by itself. So the first step in solving for time is the same as solving for distance. I'm going to multiply both sides by time. Okay, and I'm going to notice right away that I have a time on bottom and a time on top. So my two times are going to cancel out. And I'm going to get this equation that is change in distance Actually, I'm not gonna switch them this time. I apologize. I'm not gonna switch them this time. I'm gonna keep them in the same order. It'll make life a little bit easier later. So change in time times velocity is equal to the change in distance. So I've just rewritten this equation. Now notice I haven't gotten delta t by itself, but I have gotten it out of the bottom of the fraction, and that's a really good first step. So the first step on when you're looking for time is to get it out of the bottom by multiplying both sides by time. Times cancel, you get this. Now I can see now I want to get t by itself. I got to get rid of a times v. And to get rid of a times v, I simply do the opposite. So I divide by v. If I divide this side by v, I've got to divide this side by v. And you'll notice right away that a v on top and a v on bottom, well heck, these guys cancel each other out. So then I can write my final equation. I'm going to do that up here on the side here. Let me erase this x stuff. And my final equation is delta t is equal to delta d divided by v. So my change in distance, how far I traveled, divided by my velocity, gives me how long it took to do that. And now that I've solved for t, it took 2 steps to solve for t. Now that I've solved for t, I can plug numbers in. So my change in time is equal to my distance, 26.2 miles, divided by my velocity of 5.75 miles per hour, 5.75 miles per hour. Now before I do the math, I can tell I've got something that's the same on top and bottom. I've got a mile on top and a mile on bottom. Those 2 miles are canceling out, leaving me just hours behind. Okay? So my change in time here, when you do the math, is 4.56 hours. All right, that's how you do it. So notice change in time is more complicated. It takes 2 steps. The first step is get time out of the bottom by multiplying both sides by time. The second step is then divide by velocity to get time by itself, and then you plug numbers in. When you're doing your work, make sure you have units on all numbers and you're showing these 2 steps of how you do algebraically, getting it from here to here, and we show that each time. All right, now you've got 2 options. You can either click on this red box right here for another example of solving for time, or you can click on this box if you think you're ready to try one on your own. I'll let you choose that. Go ahead and pick the one you want.